review on radius of convergence, and then we'll jump into manipulation of Taylor series. All right, so if you look at this series, it says when does this series converge? For what values does this series converge? This is an old AP question. All right, for what values of x does this series converge? Okay, well, I could tell you if this series converge and diverge if it didn't have x in it. Okay, but here they're just saying find the x value where this converges. So what you have to do is force it into a ratio test. Do you remember this? This is what you did last night. Okay, everywhere there's an n, you're going to put n plus 1. Not x, though. You're going to leave the x's alone, okay? So everywhere there's an n, so x plus 2 raised to the n, you're going to change it to, you're going to substitute it with n plus 1, okay? Then what you do, because this is what the ratio test says, it says take an plus 1, divide it by an. So then what you do is you divide it by a sub n. And guys, this is a sub n here. So you basically divide it by the problem, the original, by itself, the original problem. Okay, then you say this is a giant mess, okay? So dividing fractions, easy as pie, flip the second and multiply. But make sure you understand, if you don't have to flip the second and multiply, then you're still good, okay? Not every problem is a dividing fractions easy as pie problem. Okay, so then I'm done with the a sub n plus 1 divided by a sub n. And guys, for this to converge, what must happen? Think about ratio test. What must happen? Less than 1. I'm sorry, for this series to converge. This thing here must be less than 1. All right. So what I'm going to do is I'm going to try to find x for which this series converges. Are you guys okay that this is really raised to the n here times x plus 2 raised to the 1? You guys okay if I change it to that? All right, so what I have here is x plus 2 raised to the n times x plus 2. All right, then what I try to do is cancel things out as much as possible. So what I get is a limit as n goes to infinity of x plus 2 over, and I'm going to move all my n's together because I have to take the limit anyway as n goes to infinity. So this is going to be the square root of n over the square root of n plus 1, absolute value minus 1. Okay, then guys, the x is unaffected by the limit. Are you guys good with that? It's unaffected, okay, except, you know, how n affects it. But the limit is the limit as n goes to infinity, not the limit as x goes to infinity. Okay, so you leave the x's alone. Guys, as n gets bigger and bigger and bigger, do you see the 1's going to be negligible here? Okay, so what's going to happen to this? Okay, this is going to go to 1. So what I get is x plus 2, absolute value is less than 1. I've already taken the limit. The limit only affected the factor with the n's. Okay, and then the way you solve an absolute value is you put this between -1 and 1. And I don't really want to solve for x plus 2. I really want to solve for x. So I'm going to subtract 2 from every, I guess, compartment here. As long as I do the same to each part, then I'm okay. So I get -3 is less than x, which is less than -1. Okay, and that's part of my answer. Okay, because if you notice, if I go up here and I put -3 in here, I want to make this another color. If you get -3 in here, do you see that this is going to equal 1? Right? -3 plus 2, the absolute value of that will give you 1. And if I put -1 in here, if I put -1 in here, do you see that I'll get 1? I'll get the ratio test is equal to 1. Well, guys, what happens when the ratio test is equal to 1? The ratio test is inconclusive, right? So what that means is the -3 and the -1 is not tested inside this ratio test. What I know for sure, okay, so just think about the x-axis. Whatever this function, whatever Taylor series this function represents, right? So this is equal to some sort of function. Okay, whatever Taylor series this function represents, I know for sure that it converges, okay, between -3 and -1. This series will converge, okay? Guys, actually, let me ask you a question. Do I know what the center is? What's the center? Do you see it's -2? Do you see how you can pull it out of here? Because this was x minus c raised to the n, right? It's x minus, you know, x minus -2, 1, x minus -2, 2, right? X minus -2, 3. So the center is -2. Guys, take a look at what I have. Does it make sense that the center is -2? Okay, so it should make sense there too. Guys, what's my radius going to be here? Okay, radius of 1. I should put capital R to be consistent. Okay, so if I said, what's the radius of convergence? You'd say 1. If I said, what's the interval of convergence? You know that if you look at your multiple choice, it's not D or E, but you could see it could be A, B, or C. Is everybody good with that? Okay, so what I need to do now is test my endpoints. Okay, so let's test my endpoints. I need to test -3 and test -1 because using the ratio test, it was inconclusive whether this series diverged or converged. Okay, so what I'm going to do is for my x, so test my endpoints. I'm going to test x equals -3, and I'm going to test x equals -1. So put in -3 right there. I'll get the sum of -3 plus 2 raised to the n over square root of n. Guys, now I'm replacing my x, not my n. Are you guys getting your n's and x? Are they clear to you? Which is what? Okay, so this becomes the sum of -1 raised to the n square root of n. Does this series, now this is back to your last test, does this series converge or diverge? Converge. Can you tell me why? Alternating series. Okay, so if this were a free response and I wanted you to justify this, you would say that this series converges by alternating series test. Okay, you would say because one, the terms 1 alternate, the terms 2 have a limit of 0, and the terms 3 decrease in magnitude. And I tried to write the minimum amount of things you have to write, okay? Some of you guys are cutting these things even shorter. Be careful about that because you could get it wrong. All right, so then this thing converges. So do you see that this one's out? Is everybody good with that? Because you need to have an equal sign here, and it's only between these two. All right, let's test the -1. So if I test the -1, x equals -1, now I replace the x with -1. That's -1 plus 2 raised to the n over square root of n. What do you get here in the numerator now? 1 raised to the n. But 1 raised to the n is just 1, okay? Converge or diverge? Diverge by what test? P series. What's your P equal to? 1/2. Very good. So this diverges by P series. Your P is equal to 1/2, which is less than 1. Okay, so your answer should be B, because this should have no equal sign. Okay, you guys good with that? All right, so that's your warm-up. Let's move to let's move to your first problem. All right, find the Taylor series for e to the 5x centered at x equals 2. Write the first 4 non-zero terms and the general term. Okay, so let's look at this. If I want to find e to the 5x, I know e to the x. Do you agree? E to the x is equal to, I'm thinking about the Maclaurin-Taylor series. Okay, so remember this is Maclaurin, so c equals 0. The Maclaurin-Taylor series is, okay, e to the x does not alternate. Do you remember that? And then it's kind of a combination of cosine and sine. So I'll start with 1 plus x squared over 2 factorial plus x3 over 3 factorial plus x4 over 4 factorial plus ... plus xn over n factorial plus ... If you put equals here, make sure you have the plus ... Otherwise, a lot of times I'll just put a squiggly here. All right, so what I'd like to do is I have e to the x. I want to just substitute x for 5 to the x, right? Substitution. Okay, so let's talk about this. The function is going to go from x to 5x. What is the shift there? Can you tell me the shift? No shift. Okay, so I'm going to say shift of 0. Let's look at the center. The center for the Taylor series, because I'm going to start with this series here. The center for the Maclaurin series is what? What did I start with? 0, right? What's the center that I want? 2. Okay, question. What's the shift here? Okay, so this is right 2. Can I substitute? No, I cannot substitute. So be careful, guys. We're going to start our homework now where sometimes you can substitute, sometimes you can't. So no substitution is allowed here, which means now I'm in big trouble. How in the world can I figure out e to the 5x, the Taylor series, if I can't substitute? Do I have another method? Yeah, it's a table. So you have to go back to the table. And as much as we don't want to go back to the table because it's a lot of work, sometimes if you can't substitute, there's no other thing you can do. We'll talk about different other things you can do today, but we can't substitute here. So what we have to do is say f of x is equal to e to the 5x. The derivative of that is equal to 5e to the 5x. The derivative of that is equal to 25e to the 5x. The derivative of that is equal to 125e to the 5x. And the derivative of that is equal to 625e to the 5x. And I could go more just in case, because it says I need non-zero terms. So if any of these become zero, I'm going to have to go more terms, but I'm just going to stop there because I know that's all I need. Okay, f of 2 is equal to e to the 10. F prime of 2, oops. Do you guys see why I'm plugging in 2? Everybody good? I'm plugging in the center. Okay, so this is how you do the table. So f prime of 2 is 5e to the 10. F double prime of 2 is 25e to the 10. F triple prime of 2 is 125e to the 10. And F fourth prime, but this is, then you just rewrite it. The notation changes when you get bigger than 3. So that's 625e to the 10. Okay, we're doing the Taylor series. The center is not 0. The center is 2. Okay, so be careful. That means e to the 5x is equal to, or I'm going to say squiggly just in case I forget my plus dot dot dot. Okay, first, okay, it's the bad word. So it's f of c, but my c is 2. That's my center, plus f prime of 2, x minus 2 raised to the first power over 1 factorial, plus f double prime of 2, x minus 2 squared over 2 factorial, plus f triple prime 2, x minus 2 raised to the third over 3 factorial, plus f to the fourth derivative, f of the fourth derivative of f of 2, x minus 2 raised to the 4 over 4 factorial plus dot dot dot. Okay, you guys with me so far? This is the Taylor series. You have to memorize this, okay? And be careful. This has a center, so I had to put the center here and the center here. Okay, then I substitute these numbers right here. So f of 2 I know is e to the 10. F prime of 2 I know is 5e to the 10. This one is 25e to the 10. This one is 125e to the 10. And this one is 625e to the 10. And that's basically my answer, okay? If I wanted to make it a little bit cleaner, I could rewrite it. I just realized I didn't put in my general term. So let me go ahead and do the general term here. So this is plus 125e to the 10, x minus 2 to the third over 3 factorial, plus 625e to the 10, x minus 2 raised to the fifth over 5 factorial. Okay, hopefully you guys have more room on your paper than I have here. Oh, did I do that wrong? Did I say 5? Okay, sorry, that's to the fourth. And that should be 4 factorial then, thank you. Okay, we're gonna do the general term, guys, because you guys need to know how to do the general term. So what you do is you try to find this pattern. So do you see that this is really 5 to the 1? This is really 5 squared, right? This is really 5 thirds. This is really 5 fourths, right? 5 to the fourth. So the general term is going to be, they're all positive, so I don't have to worry about like, you know, the negative 1 factor. It'll be 5 raised to the, like, make this my n, raised to the n, e, okay, they're all e to the 10s, right? So e to the 10, they're all x minus 2, so I copy that. Then this also is the n number divided by the bottom. What would you put on the bottom? N factorial plus dot dot dot. And guys, this is my general term, and you need to be able to write that. Okay, does that make sense to you guys? Let's do another one. Okay, oops, that's the same one. Okay, so what if I wanted to find the Maclaurin series for e to the x? I already have that actually. The Maclaurin series for e to the x is, and you guys have this written down, this right here. You guys have it written down on your formula sheet somewhere, right? You can also write it down again if you want to. This is the general term for e to the x. Notice everything is plus in e to the x, and you don't alternate signs, and it's not odd or even, okay? It's like it's all the odd terms and all the even terms, okay? One thing I want to warn you guys about is what students do right here is they'll put a summation here. Guys, the summation doesn't go there. Hopefully you understand that that's wrong notation. If you do a summation, you would put it out here and you would say x, oops, you put it out here, you'd say the sum of x to the n over n factorial is equal to, does that make sense? Like this would be proper notation, is equal to this. You would never put the summation right inside, like, you know, where you open up all the terms. Does that make sense? Okay, the other thing I want to say is that AP will never give you a problem where your answer requires you to write sigma. Does that make sense? So you never have to ever write sigma, FYI, okay? You might write it like while you're doing your problem and such, but the answer won't ever have sigma in it, okay? All right, so last night, if you guys look at, so this was like one of your problems last night. What problem is it on your notes? Is it problem 2 or something like that? If you guys look at your notes for today, look at problem 2 on last night's homework. Can you guys tell me on problem 2 on last night's homework, what was your interval of convergence? All real numbers, right? Negative infinity to infinity. Do you notice that problem 2 was your e to the x series? Okay, it was your e to the x series. So what it turns out is that if you take e to the x to infinity, this series will converge for every single x value. So where it says 4 on your notes, okay, this is what we would put for negative infinity less than x less than infinity. Okay, e to the x converges. So what that means is this really is an equal sign here. But, you know, of course, it has to go to infinity. All right, not every function will be an equal sign, but the ones we do here are, yeah, yes. Okay, let's look at sine of x, guys. So sine of x, a few days ago, we did the Taylor series for sine of x, but again, you can memorize sine of x also, okay? So actually you should. So we memorized the Maclaurin series for sine of x, and that was, let's see, it's an odd function. So it's gonna start with x minus x to the 1 minus x to the 2 factorial. The signs also alternate, okay? And so this is the this is x to the 5th, the memorizing for the sine function, okay? You also need to memorize the general term for the sine function. So it's an alternating function, then x raised to this is an odd number, so I call this 2n plus 1 over, and then this is 2n plus 1 factorial. Guys, I memorize like this. I just ask you to memorize like this, but I want to tell you this general term can be other things, okay? I'm starting at n equals 0, and this is how it goes. If you start at n equals 1, you'd have something different, okay? Let's see. Yeah. X minus, oh, wait, I put in an even one. Sorry about that. Okay. Okay, is that better? Let me see if I can, okay, I can't pull that in. Let me just straighten it out a little bit better. Sorry about that. That's x minus x cubed over 3 factorial plus x5 over 5 factorial minus x7. Okay, that's better. Thank you. Okay, so these have to be all odds. And if you guys look at your homework on problem 6, that was actually the sine series, okay, the sine x function. What did you get for the interval of convergence for problem 6 last night? Was it all reals too? Okay, so guys, sine x, just like cosine x, actually cosine x is going to be the same, and just like e to the x, they all converge for all reals. Okay, so just FYI, and I'm not sure if you'll ever be asked that, but that's just something to understand. Okay, so today what we're going to do is we're going to manipulate this. Okay, so what is the manipulation? If I want to define cosine x, do you agree that the derivative of sine x is cosine x? Right? Well, if these two sides are equal, can't I just take the derivative of both sides? What's the derivative of sine x? What's the derivative of x? What's the derivative of x cubed? 3x squared. And then the 3 factorial, this is just like a scalar. What's the derivative of x fifth? 5x4. What's the derivative of x7? Plus, dot, 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 plus. This is interesting. And then the general series, the general term, guys, acts just like this. So you think about what you did here. First of all, did I touch the alternating part at all? No. So then you copy this part right here, -1 to the n. Okay, then what I did was I took this number, so this is a 7, I brought it to the front, right? This is a 5, and I brought it to the front. So this is a 2n plus 1. I'm going to bring that to the front. Okay, this is x raised to some power. What did I do to each of these powers? I subtracted 1, right? So if I subtract 1 here, what do I get? 2n. Okay, what did I do to all of these denominators? How did I change them? They stay the same. So I'm going to keep the denominator here the same, 2n plus 1 factorial plus dot, dot, dot. Okay, so you have to be able to generate, manipulate the general term as well as these terms in here when you take the derivative. Now let's think about this. Isn't this right here 3 times 2 factorial? So don't my 3's cancel out there? And isn't this right here 5 times 4 factorial? So don't my 5's cancel out there? And isn't this right here 7 times 6 factorial? So don't my 7's cancel out? And then dot, 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 plus. And then this right here, isn't this right here 2n plus 1? I don't know if this is going to cancel out. Yeah, it is. This is going to be, if you brought this down by 1, isn't that 2n factorial, right? So do you see the 2n plus 1's will cancel out? So I get -1 to the n, x to the 2n over 2n quantity factorial. Guys, does that look familiar? You guys can do it. We can say ooh together. 1, 2, 3. Ooh. Okay. Does that make sense, guys? So you could, as long as you take the derivative of both sides, this works. This is kind of amazing because what it means is you can take the integral of both sides too. Okay. And you can find different functions. Like from cosine, if I wanted to find negative sine, right? Wouldn't I just take the integral of both sides? Okay. So this is just kind of neat. And cosine, just like sine and ex and sine x, it converges for all reals. Okay, so that's true for all real numbers. All right, let's look at manipulations. So what kind of manipulations are we going to do today? We've done substitution. We're going to do a little bit more, but we've done substitution. Remember, you can only substitute if the function and the center shift the same amount, the same direction. Okay, so make sure you understand that about substitution. Today, we're going to talk about how we can multiply both sides by the same variable or the same constant. We can add or subtract series 2, and we can take the derivative and integrate both sides. As long as we do both sides, we're fine. And we'll save the 5th one for later. Okay, so let's first look at some manipulation. So first, we're going to look at the function sine x squared. The function sine x squared. I want the Maclaurin series for sine x squared. Okay, if you set up the table for this, what you'll see, and I'll just kind of start setting up the table. Okay, the derivative of sine x is 2x cosine x squared. The derivative of that, do you see that that's a product rule? Do you see that? That would be minus 2x sine x squared, if I did that right, times 2x. I'm not even sure if I did this right. But do you see it's going to quickly become a big mess? Is everybody good with that? We're going to do a product rule and then another product rule, and then it's going to keep a product rule over product rule. I have no idea. It's going to become a big mess. All right. What's an alternative, if it works? What's an alternative? Substitution, right? Let's think about this. I do know the Maclaurin series for sine x, right? The Maclaurin series for sine x, I do know. That center is 0. You guys agree with that? Okay, so I want to move from the Maclaurin series to x. I want to move from x to x squared. That's the function. Can you tell me what my shift is? If I move from x to x squared, no shift. You guys good with that? No shift. Okay, let's look at the center. If I move from the Maclaurin series of sine x, what's the center? What's the center of the new series I want? How many, what's that shift right there? No, oh man, I wrote the bad word here. No shift. Okay, you guys good with that? Okay, so no shift, can I substitute? Yes, and that's really what you want to do if you have to end up with a bunch of product rules. Okay, so let's go ahead and substitute. First, you have to start with something though. So first you have to start with the Maclaurin series. Okay, so that's going to be x minus x cubed over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial plus dot, dot, dot. I want 4 non-zero terms, 1, 2, 3, 4. If they don't turn out to be non-zero, then I'll go back and change and add more terms, but I think this will be okay. Guys, you have to know the general term too. So the general term here, memorize it, is -1 raised to the n. Okay, this is the odd function, so I use 2n plus 1 over 2n plus 1 quantity factorial plus dot, dot, dot. Don't forget your plus dot, 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 or put a squiggly here, okay, to make sure what you're saying is true. What I'm going to do now is everywhere there's a sign, everywhere there's an x, I'm going to put in an x squared, okay? So this x becomes x squared. This right here, be careful. This is x squared. This quantity x becomes x squared. So do you see that that is actually x6, okay? This quantity x becomes x squared, okay? So this becomes x10, okay? This quantity x becomes x squared. So this becomes x to the 14 plus dot, dot, dot plus. Okay, so guys, what we do here, we also do to the general term. So what happened here was this quantity x became x squared. Do you agree with that? So this became -1 to the n. Okay, nothing happened with the alternating sign. Do you agree with that? I didn't change the alternating sign. So this is still -1 to the n. This now becomes x raised to the 4n plus 2. Do you guys see where I'm getting that? Okay, divided by, did I do anything with these denominators? No, so I'm just going to copy this 2n plus 1 factorial plus dot, dot, dot. And really you should go back and check to see if my general term works. If it doesn't, you can tweak it a little bit. But if I plug in, I don't know, if I plug in 0, if I plug in 0, 0, I think I do get this. This is n equals 0. Because if I plug in 0, this will be 2. If I plug in 1, this will be 6. And this actually will be negative. Okay, so actually this does work. So go back with the general term. Make sure when you plug in numbers, it actually works. Okay, so that's sine of x squared. What if they asked you for, now what if they asked you for f prime of x? That's the derivative of this, right? Well, if I have sine of x squared is equal to this, if I take the derivative of both sides, because you're allowed to, okay, if I take the derivative of both sides, wouldn't this be, on the left side, wouldn't that be 2x cosine x squared? You guys good with that? Wouldn't that be 2x cosine x squared? So that would be approximately equal to, and then we do the same thing for each one of these terms. You just take the derivative of each one of these terms. So this would be 2x minus, what's the derivative of x to the 6? 6x5 over 3 factorial. What's the derivative of x to the 10? 10x9 over 5 factorial. What's the derivative of x to the 14? 14x to the 13 over 7 factorial. Do you guys see why I'm just carrying the bottom? The bottoms are like scalars. You guys good with that? So I'm pulling it out and pushing it back in. All right, and then let's do the general term. The general term is going to be, did I do anything with the negative signs and positive signs? Did I change them in any way? No, so then that copies, -1 to the n. Okay, then where did I get this 6? Where did I get this 10? Where did I get this 14? That was just, yeah, that was just 4n plus 2. So then I take the exponent, put it to the front, then I have an x. Okay, what did I do with each of these exponents, these new exponents? Drop it by 1, so now it's 4n plus 1. Do you guys see that? Because I'm going to subtract 1 from the exponent. Did I do anything to the denominator? No, so I'm going to copy that. Okay, and that is my new general term. And of course, you should go back and check it to make sure it actually works. So yeah, I think it works because this is n equals 0. This is n equals 1. Okay, but check to make sure it actually works. All right, and if it doesn't, you just adjust it so that it works. Okay, another thing we could do, so let's talk about what we could do. We could substitute, okay, only if the function and center shift. We can take the derivative of both sides, okay? And another thing we can do is we can actually, let's see, this is a derivative of both sides. We can actually multiply both sides by the same number or the same variable, okay? But this multiplication, you have to be careful because you're not multiplying just one term, you're multiplying everything. Okay, so let's talk about this. Cosine x, let's get the Maclaurin series for cosine x. So cosine x is equal to, do you guys know it? How does it start out? How does cosine start out? 1, because it's x to the 0, they're even, right? So that's 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial. I want 4 terms, 1, 2, 3, 4, plus dot, 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 plus you need your general term. Okay, do we remember the general term for cosine x? Negative 1 to the n, x to the, this is even, so it's 2n over, and what's on the denominator? 2n quantity factorial. Guys, this is different from 2n factorial, so make sure you guys understand. If you don't have that parentheses there, I'll count it wrong because these are two completely different things. And don't forget the plus dot, dot, dot at the end because this is an infinite series, okay? All right, so what I want to do here is I want to multiply by x on both sides. Guys, do you see that this is not a substitution? I'm not substituting anything, okay? I'm just multiplying both sides by x. So the function and center don't have to shift together. Does that make sense? The function and center only have to shift together if you're actually substituting. Okay, so what I want to do is multiply this side by x. But if I multiply this side by x, I also have to what? Multiply this whole thing by x. Does that make sense, guys? Don't just multiply the first term by x, okay? So that means x cosine x is equal to, so if I multiply this by x, this will be x minus x cubed over 2 factorial plus x5 over 4 factorial minus x7 over 6 factorial plus dot, dot, dot plus. Okay, think about the general term. Did I change the signs any? No, so that's still negative 1 to the n. What did I do to every exponent? You added 1, so make sure you add 1 to the general term exponent, okay? What did I do to the denominator? Nothing, so don't do anything to the general term denominator plus dot, 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 and I'm good on this. And of course, you should go back and make sure, you know, if I plug in, and it may not start at 0, it may start at 1 or 2 or 3, it doesn't matter, but make sure when you plug in that it actually works. So if I plug in 0, I do get that. If I plug in 1, I actually do get that. Okay, I'm in good shape. All right, so that's how you multiply both sides by the same thing. You can also actually integrate both sides. Okay, so this says to integrate f of t dt. So what I'm going to do is I'm going to integrate this right here. I'm going to integrate both sides. Okay, they went, just to make sure, okay, they're saying that this is f of t. So they're saying that this right here is f of x. Okay, this right here is f of x. So this right here, okay, let me pull out the integrals for now, sorry. Okay, they're saying that this right here is f of x. So that means that this right here, you know, this whole thing right here is also f of x, okay? And they're saying, tell them what the integral of 0 to x of f of t dt is, okay? So what that means is take the integral from 0 to x, and for your function f, everywhere there's an f, plug in a t. Do you guys see that? Everywhere there's an f, plug in a t, not an f. Everywhere there's an x. Everywhere there's an x, plug in a t. So do you see there's a bunch of x's here? So what I'm going to do is I'm going to plug in a t everywhere there's an x. Does that make sense to you? Everywhere there's an f, I plug in a t, and of course this is a dt. Okay, and I want to take the integral of this. And so you can take the integral of both sides. So what it's saying is if I took the integral of this, so the integral of, I guess this is kind of funky, but t cosine t dt, if I took the integral of this from 0 to x, okay, this would be equal to this side over here. So let's, just like you could take the derivative of each term, you can take the antiderivative of each term. So what's the antiderivative of t? What's the antiderivative of t? Is it t squared over 2? Okay. Then the antiderivative of t third, t4 over 4 times 2 factorial. Do you see where I'm getting this 4 times 2 factorial? Plus the antiderivative of t5 is going to be t6 over 6 times 4 factorial minus t8 over 8 times 6 factorial plus dot, 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 plus, okay? And then, guys, this right here, I'm going to do the same thing to the general term that I did everywhere else. So did I change the signs any? No. So copy that factor there. Okay. What did I do to each of these exponents? Added 1. So do you see I get 2n plus 2 now? Okay. On the bottom, do I see I got this extra 8 and this extra 6 and this extra 4? What number is that on this general term? Okay, so it's the same number as whatever is up here, right? So 2n plus 2. And then this 6 factorial, 4 factorial, 2 factorial, do you see that that didn't change, right? So this is going to be times 2n quantity factorial plus dot, dot, dot. Okay, now this is the antiderivative, but do you see I need a win bar? Okay, so over here I'm going to put a win bar from 0 to x, okay? And then what you do is first you plug in the x, then you plug in the 0, then you put a minus sign in between. So when I plug in the x, everywhere there's a t, I'm going to plug in an x. So I have x squared over 2 minus x4 over 4 times 2 factorial plus x6 over 6 times 4 factorial minus x8 over 8 times 6 factorial plus dot, 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 plus everywhere there's a t, I'm just putting in an x, negative 1 raised to the n, x 2n plus 2 over 2n plus 2 times 2n factorial plus dot, dot, dot. Okay, first I put in x, then what do? Then I put in a 0. Guys, do you guys see if I put in a 0 here and a 0 here and a 0, do you see what will happen? You just get 0. So I'm not going to put in a 0, and then I subtract it, but then you just get minus 0. Everybody good? So this is your answer right there. This is your answer. Okay, this is what you get when you take the integral of f of t dt from 0 to x. Okay, you guys good there? The integral is really the most terrible. And the thing is, some people skip this t step, and I'm okay with it, but technically it's not correct, right? But I'm okay with it if you do it, as long as you get your right answer. I have no idea. I think they would. The whole thing is don't ever say something's equal that's not equal. So just be careful with that. Okay, let's look at this one right here. So this is your last one. Not only can you, substitute or take the derivative of both sides or integrate both sides or multiply by the same thing to both sides, you can also add and subtract Taylor series. Okay, so what I'm going to do here is I'm going to find, well, I know what e to the x is. Okay, the Maclaurin series for e to the x is what I have to think about for a while, but it's 1 plus x plus, and this one doesn't alternate. So plus x squared over 2 factorial plus x3 over 3 factorial. And this one's neither odd or even. You just put all the numbers in basically. You basically combine cosine and sine and then make everything positive. Okay, this is actually the best series, okay, plus x to the n over n factorial. That's e to the x, right? If I wanted to find e to the negative x, I could do a table, but I could also think about it and say, okay, I'm actually replacing x. If I start with the Maclaurin series, I'm actually replacing x with a negative x, okay? Can you guys tell me what kind of functional shift is that? Functional shift, horizontal shift, sorry. It's actually a 0 shift horizontally, right? I'm flipping it or I'm stretching it, but I'm not shifting it horizontally. What about the center here, guys? I'm going to start with the Maclaurin series, and they want me to give them a what? Maclaurin series. So what kind of shift is that? Okay, so question, can I substitute? Yes, so let's do it because substituting is way easier. Okay, so be careful with this, guys. This says everywhere there's an x, I'm going to put in negative x. Okay, this is a 1, so you would not replace anything there, right? This is a 1. This is an x, so this becomes negative x. This is an x, but it's a quantity, so this quantity here gets replaced with negative x. Okay, this quantity here gets replaced with negative x. And this quantity here gets replaced with negative x. Okay, which means down here, this quantity here gets replaced by negative x. Okay, so that's e to the negative x. And I can do the substitution because the function and center shifted together. Okay, so given this here, do you see what I want to do is add these two things together? Do you guys see that? And then divide by 2. Okay, so if I add these together, I'm actually not sure what the general term will be. This right here, I'm just doing this kind of thinking aloud. This will be negative 1 times x raised to the n over n factorial, which actually is negative 1 raised to the n, x to the n over n factorial. That's actually what this becomes. Well, let me actually just do the whole thing. This becomes 1 minus x. Okay, what's negative x squared going to give you? A positive. Okay, what's negative x to the third going to give you? A negative. Okay, what's negative x to the fourth going to give you? A positive. Plus dot 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 plus. And do you see you end up with an alternating series? And do you see on my general term, this is actually a happy thing. I actually ended up with that alternating factor. Okay, x to the n, and let me just check to make sure this is true. If n is 0, that works out. If n is 1, yeah, that works out. If n is 2, yeah, that works out. Okay, so this is my e to the x. All right, so what do I want to do with e to the x and e to the negative x? I want to add them together, right? Okay, so if you guys are okay, I'm going to wipe out this thing right here because this was kind of my process. Okay, so I'm going to add these things together and divide by 2. So guys, add these together. What's going to happen? Do you see what happens when you add these together? Yeah, you're going to get e to the x plus e to the negative x is equal to 2. And then the odd terms are going to wipe out. Like these terms are going to wipe out. These terms are going to wipe out. So this will be 2 plus 2x squared over 2 factorial plus 2x4 over 4 factorial plus, and I can imagine what's going to happen here because I can see the pattern here. This would be 2x6 over 6 factorial dot dot dot. You guys see how that works? Plus, and then this would be, what am I doing? Basically just multiplying by 2, but I'm only taking the, okay, this is way hard to do. I'm just going to make up my own. You can make up your own too. Do you see this is really just 2x to the 2n, right, over 2n factorial. It was a lot easier just to make up my own. Okay, you guys good so far? But what do I need to do to both sides to make it look like this right here? Okay, so I'm going to divide this by 2, divide this by 2. Okay, and so do you see I get h of x, which is what they asked me to find, is equal to e to the x plus e to the negative x over 2. But guys, do you see when you divide by 2, all of these first, I don't know if you see, all the 2's cancel out. So this becomes 1 plus x, this 2 cancels out with this 2, right? This 2 cancels out with this 2, this 2 cancels out with this 2. So it becomes 1 plus x squared over 2 factorial plus x4 over 4 factorial plus x6 over 6 factorial. I think I just need 4 terms, right? Yeah, 4 terms. Okay, so that's 4 terms plus dot 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 plus. And really what happens is just the 2 wiped out, right? So this is x to the 2n over 2n factorial plus dot dot dot. And we're done.